Welcome students to the conics chapter. We're going to start by the first video by the ellipse. First of all, a conic has an equation, general equation ax squared plus by squared plus cx plus dy plus e is 0. If a equal to b, coefficient of x squared equal y squared, we have a circle. You know it from before. But if a and b not equal, different, but same sign, A and B both positive or both negative, we have what's called an ellipse. What is an ellipse? An ellipse is the set of all points whose sum is equidistant from two fixed points called focus. We know that in a circle definition, you have a point. If you pick any point M and you measure the distance, if you want to find the set of all points equidistant from this point, which is called the center, forms a circle. And if you pick any point on the circle, so it has the same radius. However, in ellipse, we are not talking about one point, we're talking about 2 points. And if you pick a point, P, like here, and you measure from P to F1 plus P to F2, you have a sum. And you pick any point, any other point having the same sum, whatever, they form an ellipse. We have two forms of ellipse, horizontal and vertical. Let us go to GeoGebra first of all. I'm going to graph an ellipse. Later on, we're going to know how do we graph ellipse. I'm going to take an example of horizontal ellipse. Sorry. Equal to 1, I must put. So this is my ellipse. If you pick here the focus of the ellipse, suppose the focus of conic here A. So these are the two focuses. If you pick any point on the periphery and you do the segment joining this point to the first fixed point and this one to the other one, here you have F and G. And if you make the sum, F plus G, it's 6 as you can see. If you do animation on C, you're going to see whenever the point move on this one, F and G, these two distances differ, but their sum is fixed and will not change. It's equal to 6. Now, every focus has 4 vertices, 2 vertices and 2 co-vertices. Okay, so we have 2 vertices and 2 co-vertices. So as you can see, I have 4 vertices. Here you have 0, 2, whatever. I have 1, 2. This ellipse is horizontal. As you can see, when it's horizontal, it has major axis parallel to the x-axis and minor axis parallel to the y-axis. And if you want to take an example of an ellipse, vertical ellipse, let us take an example. So this is an ellipse which is horizontal, vertical. So you have the focus, and if you pick a point here, same story, and you measure the distance from C to B and C to A, and then you make the sum of these two segments, F plus G, and you do animation of the point C, you're going to see it will not change. And this conics have vertex. I have 4. Here vertical, this is the minor axis parallel to the x-axis and the major axis parallel to the y-axis. Anyway, so to start the equation, let F1 and F2 be 2 points and this is the origin, midpoint of F1 and F2. Let us denote by C the components of the first F and minus C. If you pick any point M, we said that the sum of the distances is equal to a constant value. Let this constant value, we're going to prove it that it's equal to A. So this is the proof, and you're not responsible of. At the end, we have this equation. So what concerns us is that what is the difference between vertical and horizontal? For horizontal, if under A square is bigger than under Y square, here we're going to take for granted that A is bigger than B, always. If under X square is bigger, so if you equate Y to 0 to find the X intercept, you have plus or minus A. Since it's bigger, so here the distance will be bigger than this distance, which is B, if X is 0, so Y will be plus or minus B. So these are the two vertices, these are the two vertices, and this is the focus, and O will be midpoint of these 2 points, the vertices, and the midpoint of the co-vertices, and midpoint of the two focus. And if under Y square is bigger, so A square here is here, so it will be the same story, but it will be vertical. So let us go directly to application problem. It will be very simple for you, but before, I want to find the relation between C, the components of the focus, and A, which is, we said, this distance from A to the vertex, from that side or from that side the same, and B, the distance here. We said that if you have any point on the periphery, no matter where you put it, the sum of the distance from QF1 plus QF2, we said it's equal to A. So why to A? Because if you have this point Q is P here, so PF1 plus PF2, so PF1 plus PF2 is the same as PF1, PF2 equal to F1R, so it is 2A, from here to here A, and here to here A. So because this triangle is isosceles, and this is a perpendicular bisector, so these two are equal. So since they are equal, so this is a small a, and we know that this is C and this is B. We can apply Pythagorean theorem. We say B square plus C square equal A square. So always the component of the coordinates of the focus is equal A square minus B square, vertex square minus co-vertex square. So we're going to graph here. First of all, we're going to say that this is an ellipse because coefficient of x square and y square, same sign, but not equal. Both are positive, but not equal. Here 1 over 25, here 1 over 16. So it's an ellipse. Horizontal because under x square is bigger. Because under x square is bigger, so horizontal. So we're going to start. First of all, the center is 0, 0, like we used to do in this circle, 0, 0. Now we have a square. This is always the biggest one will be A square is 25. Because it's horizontal, it must be on the x-axis. So we say 50 A and minus 50. The co-vertex will be on the y-axis. B square is 16, so B is a plus or minus 4. So 0, 4, 0, minus 4. The focus is always on the major axis, so it follows the vertex, not the co-vertex. So F will be, like we started by a number and 0, here we say C square is equal to A square minus B square, which is 9, and C plus or minus 3, so it will be 3, 0, minus 3, 0. And the major axis parallel to the x-axis equal to A, which is 10, and the minor axis equal to B parallel to the y-axis, it will be equal to 8. And now we have still to talk about the eccentricity. Eccentricity is always a ratio between C and A, because here C, this is C as we said, and this is a tilt of focus C. Since C is smaller than AC over A and ellipse, always the eccentricity less than 1. And if you pick a point here M, no matter where M is on the periphery, MF1 plus MF2 always equal to 2A, and so F1, F plus MF prime, the distance equal to A, and since A here is 5, so it will be 10. Now let us take an example of a vertical one. First of all, this is ellipse because under y square is bigger than under x square, and you have a plus. So ellipse not equal, so ellipse. So vertical because under y square bigger than under x square. Center 0, 0 because it's vertical, so the vertex will be on the y-axis. So here we start by 0. Always when vertical, we start by 0, plus or minus 3. Co-vertices will be on the x-axis, so 2, 0, opposite to the one we did up, minus 2, 0. The focus follows always, it's on the major axis. A square minus b square, so 5. So c plus or minus radical 5, it follows like a 0, 0, and 0, 0, minus radical 5 and radical 5. Eccentricity c over a, so radical 5 over 3 less than 1. Major axis parallel to the y-axis equal to a, which is 6. Minor axis, which is b prime, parallel to the x-axis equal to b, which is 4. Now I want to take examples where the center is not anymore the origin. So here, first of all, the center here, as you can see, like in circle, is 2, equate this to 0, minus 1. Ellipse plus, same sign, the coefficients, but not equal. Under x is bigger, so it's 9, because it's 9, bigger than 4, so it is a horizontal. Now the center is 2 minus 1. So how are you going to start to find the vertices and all the characteristics of the ellipse? First of all, I'm going to take, for example, as I, the new system, x, I, the red one, y, I, not this old one. So when you take this one to be I as the new origin, as if I'm taking x squared over 9 plus y squared over 4 equal to 1 without this. So like we did before, a squared is 9 because it's horizontal. We start by number then 0, 3, 0, minus 3, 0. B squared is 4 because it's horizontal, so 0, 2, 0, minus 2. And the focus will follows always the vertices. So plus or minus radical 5. So radical 5, 0, minus radical 5, 0. Eccentricity c over a, less than 1. Major axis here, parallel to the x-axis equal to a, which is 6. And minor axis parallel to the y-axis equal to b, which is 4. Now I want with respect to x or y. Here you know you took in grade 10 9 and 10 the translation. So here every point I must switch it 2 units to the right and then 1 down, like the slope. Okay, run and then rise. So to switch it like this, so because I want now with the respect to this origin, this is a translation. So directly I add for every x2 on all points and for every x minus 1. If you add 2 here, you're going to get 5, 2, 2 plus radical 5. Here, 2 minus 3 is minus 1, 2 plus 0, 2, 2 minus radical 5, 2 minus radical 5. And you add for every y minus 1, minus 1, 2 minus 1 is 1, as you can see, minus 1, minus 1, minus 3, and and 0 minus 1 is minus 1. Now, if you want to graph it now, you want to graph it, so we put the center, which is 2 minus 1. The point A with respect to x or y is 5 minus 1 here. But with respect to x, I, y, the red one, so the point A here is 3, 0, 1, 2, 3. But what I want this one, the real x or y. Point B, for example, here 2, 1, 2, 1. Sorry, from this system, 2, 1. Point A prime is minus 1. This is the origin, minus 1, minus 1. This is A prime. B prime is 2, minus 3. So I have these points, I graph it. If you want to, with respect to x or y, you can graph it. You take 3 units to the right because horizontal, 3 units to the left, and then 2 units up and 2 units down. So these are the coordinates with respect to the red one. But to have the complete grid, you need to write with respect to x or y, not with respect to x, I, y. Another example, here also the center is minus 1 and 2. It is vertical because under y is bigger. So as we said, a square is a 25 because vertical, the major axis parallel to the y-axis. So 0, I start by 0, 0, 5, 0, minus 5. B square is 16. So I put 4, 0, minus 4, 0 because b prime parallel to the x-axis. C square is equal a square minus b square, which is 9 plus or minus 3. And always focus, follow the vertices. It will be 0, 3, 0, minus 3. Eccentricity C over A, 3 over 5. Major axis parallel to the y-axis equal to A, which is 10. Minor axis parallel to the x-axis equal to B, which is 4 times 2 is 8. I want with respect to x or y, as I did before, I add for every x minus 1, here and here, and I add for every y 2. So if I graph it, this is the center, minus 1, 2. A minus 1, I go 7 up, this is 7. A prime minus 1, I go down minus 3. B 3, 2, this is the origin, 3, 2, and minus 5, 2. And you have the focuses, you can put it. If you want to talk with respect to the red one, x or y, you go upward 5, downward minus 5, as you can see here. To the right, 0, 4, 1, 2, 3, 4, and 0, minus 4. But concerning me, if I'm asking about vertices, you must put these, not these. This will be wrong. We're writing with respect to x or y, not with respect to x or y. But if to go to x or y, we must pass by x I y first. The last example, if it's written in the not standard form. So here, this is not standard form, 25x squared minus 100x plus 4y squared plus 24y plus 36 equal to 0. First of all, I'm going to say this is an ellipse. Why? Because coefficient of x squared and y squared not equal but same sign. They are both positive but not equal, so this is an ellipse. So I take the x's together, as I did here, and the y together, and the number to the other side. I put coefficient of x squared in factor, 25. I divide by 25 here, 25. I put coefficient of y squared in factor, so 4. I divide by 4 here and 4 here, equal minus 36. Now I want to write canonical. To write canonical, you took it in grade 10. So you put big parentheses. X squared will be x. Now you look at coefficient of x. Now it's minus, you put first of all minus. You divide the coefficient of x by 2. Here you have 4, you put 2. Then you square it. Then always you put minus. Remember well, you put always minus. And you square this number outside. 2 square is 4. Let us do reverse to check. X minus 2 squared is of the form a minus b squared. So a squared is x squared. Minus 2ab minus 4x plus b squared, you have plus 4. And then I have minus 4. That's why always I put minus this number squared to cancel. So I have x squared minus 4x, which is correct. Here, the same thing, I put all square. Y squared will be y. You have a plus, you put plus. Before I had minus, I put minus. I divide the coefficient of y by 2, like I did here. 4 by 2 was 2. Now 6 divided by 2, 3. Always I have minus. I square this number outside. 3 square 9. You can check by the same way. Y squared plus 6x plus 9 minus 9 cancel out. It remains y squared plus 6y. Now I expand. This is distributive property. So I multiply first of all 25 by x minus 2 squared minus 25 times 400. 4 I multiply it by y plus 3 squared, as you can see, and 4 times 9 by distributive property 36 equal minus 36. These two cancel out. Take the minus 100 to the other side, 100. Then divide here all by 100. If we divide here by 100, so 25 over 100, so you're going to get 4. And 4 divided by 100, you're going to get 25. This is my ellipse. Now I'm returned back to the example number 3 and 4. First of all, the center is 2 minus 3. And this is vertical because under y square is bigger. A square is a 25, so a is minus 5 because vertical I started by 0, 5 and 0 minus 5, and b square is 4, so the co-vertices will be 2, 0, because vertical minus 2, 0, and the focus follows these. Because the center is 2, minus 3, I add here 2, you're going to get 2, and here minus 3, 5. 2 plus 0, 0, minus 3, minus 5, minus 8. 2 plus 2, 4, minus 3 plus 0, minus 3. 2 minus 2 is 0, minus 3 plus 0, minus 3. And the same for the focus. You have the eccentricity. This is the midpoint. Center 2, minus 3. You have 2, 2. This is the first point. 2 minus 8. This is minus 8, the second point. 4 minus 3, this is 4, you go down minus 3, and you have 0 minus 3, so these are the vertices. You can graph the ellipse, and these are the two focus. I hope that you got the lesson of the ellipse. I will see you in the second video about hyperbola. Thank you for listening.